Hello.
Hello.
Hey, can you allow screen share permissions for me?
Yeah. Can you see my screen?
Yeah, I can see it.
Okay, I'll start allowing people.
Sounds good.
Hello, everyone.
Hello. Happy Sunday, folks.
Let us know where you're joining from. Just a fun thing. It's always nice to see. Hi, Praveen from Pune. I'm thinking it's the same folks. Montreal. I've been asking you to write again and again. Mayank's from Bengaluru. Connecticut, Chicago. Thank you for joining us on a Sunday morning or Sunday evening.
Awesome. Thank you, Mayank. Akshay, I see a question. Maybe we'll take it at like some point of the like I have a point in mind in the session. We'll address it there. Awesome. I think we are yet to see folks from Europe, maybe. I think we've seen like a lot more from Europe yesterday.
Issa is here, I think, already.
Oh,
Yes, I can
nice.
see her.
Yeah, she's one of the particular persons I had in mind, so that's good. Uh, for questions related to recording the QR code on the screen right now, has a list of all the sessions that we've been doing and list of invites for like the upcoming sessions as well. So you can just scan the QR code. And this session will also be recorded and sent to you as an email after the session.
Let's wait for 2 more minutes and then we can get started. Arun is here.
Hey, Aishwarya and Kirti. I was trying to find the day to recording, and I got the email, but when I clicked the recording link from the email, it was just taking me to the event info page, but I don't really see like a link on that page that gets me to the recording. So I was a little bit confused, like how I should navigate to the recording.
I see. The event page should show you the recording. If it's been uploaded, I can check it right after this session, but that is where it should be available. I will check it again. You should also have received an email with the Zoom recording and password. Did you check?
I just received like one email with the recording link, but I can definitely check again. But the email that I received with the recording link, when I click on the recording link, it just takes me to the event page for day two, where it just says I have successfully signed up and share the lessons, copy link, so on and so forth. I don't really know, like maybe the UI is a little bit confusing for me, but I'm not sure like which link I should be clicking to like get to the recording.
Give me a second. Let me check on my end if I can see the recording. I can seem to see it. Let's do something.
Actually, I can see the recording too. This is from yesterday's recording.
I see. Interesting. Why? Then why can't
Yeah.
some folks see it? Nishan, maybe send us an email at problemfirst.ai@gmail.com. I'll try to loop in Maven support to see what's the issue, right?
Yeah,
And
also check out this page, this link below. If you just enter your email, you should be able to watch the recording. If you're not, let us know in the email.
yeah, and someone also posted the Zoom recording link with the passcode. Just copy that down. I think that was definitely working.
Yeah, and I still don't see it. Maybe something wrong on my end, but I'll just use this link and I'll also send the email if necessary.
Awesome. I think it's 9:06. We can get started. Okay. Again, thanks everyone for taking time on a Sunday. It's really good that you spent to chose the weekend with us. Today's session is about single and multi-agent systems, right? And if you've been doing anything AI, you know for a fact that there have been all of these discussions on whether you should be using single agent systems, multi-agent systems, and how should you get started with it. Just quickly checking. Kiriti, we are recording, right? Okay.
Yeah, we are recording. Maybe also turn off the chat and we can enable it at the end of the session.
Yes, let's turn off the chat. Otherwise, everyone will get distracted. We'll turn it on at the end again, folks. Want to make sure you have your eyes here. Okay. So I will bring back this OG diagram that I have been showing you since session 1, just so that everybody comes on the same page, right? We started off saying that everybody was happy with generative AI, and then they were like, Gen AI is nice, it's chatty, it can talk to us. Can we do something better? Can we make these systems generate actions as well? And that's when we went to this entire paradigm of agentic AI, right? Where we said, let's connect AI models with tools, with memory, let's allow them to plan. And when we we do that? They can do much bigger tasks as compared to just chatting, and they can complete tasks end to end. And this is kind of the image we've been showing for a while now. Now, generally, when people say agents, they're referring to systems that can perform tasks end to end for you, right? Like you ask them to book a ticket or something like that, they can do that end to end. And there's some AI model sitting in between, and that's almost like the brain of your agent. But I'll show you two scenarios which both of them do the same task, but in very different ways. And that's where we'll establish what types of agents are, right? And to just give you an overview how you could solve the same problem. Now, imagine I asked to generate a quarterly performance report for our sales department, focusing on revenue growth. Say I'm a company, I want to understand what is the performance report, how we're doing in terms of sales. Now, one way you could do this is to build an agent that is connected through multiple LLM calls. LLM here means AI model, could be multimodal, whatever. Just assume that it's an AI model. What I can say is I can prompt my first LLM to say, get revenue of the sales department from January to March. Let's say we're looking at Q1. What this LLM will do is it will call a tool. It will select the sum of sales amount from my database. Let's say I'm storing all of my sales department information in a database. And then that database will come up with the information saying that the revenue for each of the organization and sales is blah, blah, blah. And then I take that information and then I call another LLM and say that using this revenue data, find the highlights, find the lowlights, and compare it to previous 2 years report. And I also give it with 2 years report, which is the memory. It can probably be a bunch of other reports, right? Now, this LLM understands all of this and it says, based on last 2 years reports and based on what I've seen, this year there's been an increase in sales of this particular product and all of those, right? And finally, I take that information, I connect it to the next LLM, and I say, based on the revenue numbers and analysis, generate a performance report in the particular format that I want. And maybe I can give in, because it has used memory, which is structure of my report, it can look at that and generate it. And finally, I say that dump this back to my memory. Like I have 2 years report, now add this as the third year quarter one report kind of. If you see here, the task is being completed end to end, but I'm doing so much of the orchestration. All of these green arrows you see is basically I take the output, feed it into the input of the next LLM call, etc. A lot of people do call these agents, but more of agentic systems, but more of workflow kind of agents, right? Because I'm giving these AI models a lot of orchestration, a lot of decision making. All I'm allowing the agent to do, or all I'm allowing the AI model to do, is to look at information and come up with responses, right? But still the task is still being done. You can think of another kind of agent for the exact same task, where I say generate a quarterly performance report for the sales department focusing on revenue growth. And I can allow the AI system itself to devise a plan on its own. I will just say, this is your sales revenue database. This is the past year performance reports. Now you come up with a plan on how you're going to break this down and how you're going to generate it, right? Then when I prompt it that way, then the agent can call itself multiple times. Basically, instead of me having to design all of these LLM calls, the agent itself can loop around multiple times and say, this is the plan I'll go ahead with. I'll first get a revenue details from the revenue database, then I'll compare it with past year reports. Then for the style, I can copy paste last year's style, right? Here, the agent is kind of making those decisions for me. If you see, they do the exact same tasks, but how much of orchestration it takes from my end or from the user's end is completely different in both of these things, right? And that's why I named these as type 1 and type 2, just for the sake of this session, just to explain the differences between it, right? In type 1 agents, which Anthropic calls as workflows, we can stick to that, but let's just call it type 1. These are agentic systems, but with limited autonomy, right? They only have what we can call as action autonomy, which means that they can probably take knowledge, they can generate responses out of it, they can take tool responses and they can convert it into language and things like that. And humans make most of the decisions here. And AI is used for understanding generation or task execution and stuff like that. And if you really look at agents with the mindset of autonomy versus control trade-off, which means that how much control do I have in this agent versus how much autonomy am I giving this agent, type 1 comes somewhere here, right? Because it only has action autonomy. It's high on it's high in terms of human control. And type 2 comes somewhere here because it's also having the action autonomy plus some amount of planning autonomy. I'm allowing the agent to also make decisions on my behalf. So they have planning autonomy, they can decide how to do it and what to do, and plans are generated autonomously as well. And this introduces a little more non-determinism in the behavior as compared to type 1 agents. But depending on your use case itself, you want to choose type 1 or type 2, depending on what is the risk appetite you have, depending on how easy is it to come up with a plan for a human versus let the agent generate it itself. You go for a type 1 or a type 2. This is the difference between what people generally call as agents and stuff like that. I wanted to explain this to you because this makes sense before I explain the next concept, which is multi-agent systems, or MAS. It's just an acronym that's used for multi-agent systems, right? So what exactly is a multi-agent system? Generally, a multi-agent system refers to setup with multiple type 2 agents, not type 1 agents. So why are we calling an MAS only with type 2 agents? Because type 1 agents are generally focused a lot on execution. So there's very little emphasis on planning or inter-agent interaction, right? So they're so tightly orchestrated, there is no scope for interaction with other agents and all of that. So generally when people say we're building a multi-agent system, it refers to building a system with multiple type 2 kind of agents. Also remember that type 1 and type 2 is a spectrum. It doesn't always mean that type 2 is totally autonomous and type 1 is totally orchestrated. You could have something right in between here, right? Some parts of your task might be automated, some parts of your task might be pre-orchestrated. So it's not very rigid, but generally some agents that are tending to the type 2 behavior are the ones that are part of multi-agent systems. And remember that in multi-agent systems, each agent should have some level of planning autonomy, meaning it can independently decide what to do and how to do based on the task it's given. And remember, we said each agent comes with some memory and tools and all of those things. So each of the agents in a multi-agent system has its own set of memory, own tool access, and all of these things, right? Sometimes it is designed in a way that it can be shared among agents, but it's a design decision. When you start off, you will assume that each of them has their own, suite of things that they'll get work done with. And also remember that this is super important. Multiple agents not equal to a multi-agent system, right? You could have hundreds of agents in your enterprise. If they don't interact with each other, you don't call that a multi-agent system. The juice or the crux of a multi-agent system is the fact that agents can interact with each other. If these lines are not there, if they do not communicate with each other, there's no point calling them a multi-agent system. It's just multiple different agents that are out there, right? There are tons of resources outside that speak about design patterns and how different agents interact with each other, how you should be building different design patterns and all of that. They generally boil down to two different kinds of categories, right? One of them is what I call the hierarchical patterns, where you have one decision-making agent which assign tasks to specialized agents, right? This agent is called orchestrator agent. So you can decide what the specialization is depending on the task itself. Sometimes it's just about parallelization. The same task is given to different agents to make it faster to get the response. Sometimes different tools are given to different agents so that each agent can call its own set of tools and come back with the answer. Again, it entirely depends on the design, but this is one type of design. The other design is you have a bunch of different agents, allow them to talk to each other, and there is no hierarchy here. It's a flat pattern. A very lay person or watered down explanation of this is, here you have a manager who's giving tasks. Here it's a flat organization. Everybody's like communicating with each other. Also think of it in the sense that in design 1 versus 2, where is there more non-determinism, or where can more chaos occur, just even in the human setup, right? I won't give that answer, but I'll leave it to you. So in both of these designs, the thing is that in this manager kind of setup or an orchestrator kind of setup, it's more controllable just because one agent is making decisions while the other agents are getting tasks from the orchestrator or getting very specific directions from the orchestrator. So this kind of pattern is used for more controllable approaches. This kind of pattern is used for more dynamic approaches, right? Think of like when multiple agents are critiquing each other, when they are kind of debating with each other, it could lead to some differentiation influences an opinion, which could lead to better responses in some use cases, which makes sense for more creative processes, right? Maybe you're writing an article or something like that, where it's okay for some non-determinism to creep in. In most of the enterprise use cases, this one is chosen, or this one is what people do to start off with. So now you figure out that, okay, there are multi-agent systems. It looks pretty cool. Instead of using one agent, we could kind of, divide your work into multiple different agents. So are they for the win, right? I'll give you a very simple example to show how, things can get a little complicated when you deploy multi-agent systems. This is a very personal example. I think at least 20 to 30% of the folks who joined the call today kind of know that I left my job about 3 weeks ago, and I started a AI consulting firm to help companies deploy AI systems, right? And let's say I want to bring in agents to make my workflows pretty much, to make workflows simpler, and also to do stuff that I really like and reduce the amount of time that I spend on doing repetitive tasks. To really think of what an engagement looks like for me, this is how a workflow would look, right? I would check requests, some inbound requests from a bunch of clients that I'm getting. Then I would choose a few selected clients and send them a proposal. Then we fix on timeline, schedule meetings, do discovery and things like that. And then we complete billing for the client and get a reference, right? These are the operational procedures that it takes for me to complete an engagement with a client if, say, I'm building a consulting company. Now, remember that I want to spend most of my time on this part, which is, in this part, which is I want to be part of my meetings. I want to be more present. I want to talk with my clients. I want to give them advice and stuff, right? The rest of it is stuff that is operational. I don't want to do. So let's say I want to build a bunch of agents to do this, right? And I come up with 4 different agents to do this for me because I've mapped down my processes into 4 different parts. I say I'll have a lead intake agent. And what that agent does is it looks at my email, it looks at my website. And if there are some prospects who have signed up on my website or email, it basically consumes all of that information and gives me a summary of what are their proposals and which ones I should be choosing, and helps me prioritize, right? And then I have my proposal agent, which says, okay, once you've made a selection of which prospects you want to turn into clients, I will draft a proposal for them. Remember that a lot of proposals are very repetitive in the sense that if you give a bunch of examples, then it should be straightforward to at least come up with a draft of a proposal. So let's say that my proposal agent kind of drafts a proposal. It has access to my email. It has access to my calendar because it wants to see if I have availability or not. And it has also access to my proposal knowledge base where it picks up all the information and then sends proposal to the client. Then there's a scheduling agent which works with my client to kind of say what are the meeting timings that we can get started with. Again, it has access to my calendar and email. These are the tools that each of my agents have access to in order to perform their tasks, right? And finally, let's say everything went well. There's a billing agent that has access to, say, my QuickBooks and also my email and sends the billing details. I put all of these agents in the mix. I say you coordinate with each other and you make sure that I have a seamless workflow because I want to spend most of my time along with my clients and advising them, right? So this is how I put together a system. Now, what is my expectation here is that my lead agent, let's say I have a new prospect, Acme Corp, a random name I made up, with a desired start date in 2 weeks. The proposal agent reads the intake, drafts a proposal, and passes it to the CEO. The scheduling agent books a discovery call that matches both sides, and it also books, other calls after the discovery call. And the billing agent sends the invoice after the proposal is signed. I'm super happy. Like, this is how my happy workflow should look like. Now, things start to go a little weird when when parts of this process do not go as expected, right? Now, this is some expectation versus reality kind of scenario that I made up, right? Now, let's say there is a scenario where this Acme's procurement team comes and tells me that the discovery call is not something that I'm okay with. I want a later kickoff. Now, scheduling agent shifts the discovery call because the responsibility of the scheduling agent is to make sure that it schedules at the right time. So that request gets routed to my scheduling agent and it shifts the discovery call. Now, nobody notifies the proposal agent because it's directly not the proposal agent's responsibility. The proposal is still mentioning the original kickoff date, right? Now, the billing agent invoices the wrong project dates because it looks at the outdated proposal because it's picking up the proposal that the proposal agent created like a while ago before all of this happened, right? Now, the result is the client sees a conflicting information in the billing system and questions my professionalism, right? Then I think, okay, these kind of things happen. So the resolution would be that every time the scheduling agent makes any changes, it should pass context, like, or makes changes in the discovery call, it should pass context to the proposal and billing agent, right? And I will show you yet another example just to give a little more drilling down on this. Let's say now the prospect adds a new requirement, right? Or my client adds a new requirement to say that we need a data privacy workshop in the middle of the engagement. This was not part of my original proposal. Again, the scheduling agent is responsible for this, so it schedules a meeting. The proposal agent doesn't know about this because the change is made after the proposal is finalized. And the billing agent is using the old proposal, and we don't charge the client for the extra session that we did. The client ignores this because they're going to save money because it's not added on their proposal. But I am super disappointed, right? Because we conducted a session, we finished the billing. Now I can't go back to the client and say that we forgot to add something on your bill, right? Then I figured out that, okay, for both of these instances, it really makes sense that the scheduling agents schedules any new workshops after the proposal has been signed, and the proposal agent and the billing agent should kind of go through this information. And I start seeing a lot of issues like this where there is some stale information that is lying in my agents. So I say, let's screw this. I'm going to give all of my agents all the information that's happening, right? Which means that if the scheduling agent is seeing something come through it, that context will be given to my lead agent, to my proposal agent, to my billing agent, and all of that. So everybody's on the same page, like nobody's having partial information. Now, the issue with that is that AI models have a fixed context length, which means that if I give too much information to all of my agents, it becomes super hard for them to focus on what is important, right? Imagine the lead agent is sitting there looking for new emails to come to make decisions, and then it constantly keeps seeing discussions between the scheduling agent about when to do the scheduling for the calls. Then it gets confused, right? Who's the client, who's the prospect, and things like that. And LLMs have this specific issue called lost in the middle, which means that if you give them a lot of information close to their context length, they get confused, or they do not understand the parts in the middle. They understand the parts in the beginning and the end. The parts in the middle, they get lost, right? There are a bunch of issues with LLMs like this, right, which have to do with context length. So it does not really make sense to give all of this information. So I'm quickly approaching a phase where I'm thinking, if I had to do this, might as well have a single agent, right? Like I will call that my COO agent. And the good part about this is that it has the entire context. And the only issue that I see here is the context length issue still remains, right? But if you really think of it, a lot of the issues that we saw in my previous workflows come from the fact that agents have different states. They are seeing a partial part of the entire workflow, which makes it super, super hard to coordinate with each other. So when tasks like this are highly sequential, it really makes more sense to start with a single agent, is kind of the hypothesis that I have. Now I will give it to Kiriti to explain, if we went that route, what would be the issues and what would be the pros and cons.
Awesome. Thank you, Aishwarya. Let me share my screen. Okay, you guys can see my screen, right?
Yes, I can.
Hello.
We can see your screen.
Okay. Yeah, I think my internet is a bit
Hey,
glitching.
Aishwarya, this is Naresh. I don't know, it's for everybody. For me, I felt like you're too fast. Like if you can slow down, that will be great.
Yeah, that's because we do want to cover a good amount of content, and we're trying to adjust
Yeah.
pace to
I
different
agree.
people's
I agree.
understanding capabilities, and that's why it's recorded, right? So hopefully, like, it's very hard to make sure that everybody's at the same pace. Hopefully you can see the recordings.
Yeah. Okay.
It's also the same philosophy we follow. We always want to over-deliver rather than under-deliver in a particular session. And even in the course, like, we basically try to give you as much information as possible, and then you can piece things together.
Okay.
Cool. Okay, so to continue the discussion that Aishwarya was mentioning, if you have a single agent, these are the advantages that you will have, right? For example, you can have like single source of truth. So your single agent is essentially keeping track of everything that happened during the process, and one memory holds every fact. So it's not like there is like multiple sources of truth, and you need to identify whether they are in sync and whether you're like doing the right thing based on the information that you have. So you're kind of having like one source of truth or like one log. And also there is no coordination lag because you're not handing off to different agents, and kind of expectation mismatch is not happening where you expect the agent to do something and then they either like repeat what you've already done or do something which is not expected from you. So there are like no race conditions and there are no timing errors, like the handing off between scheduling agent and the billing agent, for example, in the previous slides. Also, single agent gives you simpler debugging. Like all your logs, all your agent actions that you instrument your system with have like one place to live instead of having like a delineated list of logs, which also is easier for like debugging. And in general, lower cost. And remember that all of these are good pointers for like use cases. And in all our experience, 90 to 95% of the use cases that we build systems for and we've seen in the wild have not a strong requirement for multi-agent systems. So do not like go for multi-agent systems just because they're fancy. Like start with single agent systems and make sure you're solving all of these problems, and then you can go for the multi-agent systems. And another advantage of single agent systems is like you are running essentially one loop of LLM, and that means like you only do the calls that are required. You're not doing additional calls to set context for agents like multiple times. So that means like it's easy maintenance, easy deployment, and system management, fewer tokens and API calls at the end of the day to achieve the task. Now, you could also say what is the issue with context limits, because when you're using a single agent, you would still face a problem like this, where you're trying to stuff all the context into the single agent that is trying to do the work, and then the context limit can be reached. So this is where context engineering is extremely helpful. And the word context engineering is like a big bucket of things that you can actually employ, or like techniques that you can actually employ to make sure you're not hitting the context limits and providing the right context to the LLM all the time. We covered the context engineering in the lesson one in depth. So here I'm only going to like explain at a high level where context engineering essentially can be done in like multiple ways. You kind of imagine like you only have like one page of content that you can provide to an LLM at a time. Now, do you really keep track of everything, or every time you want to refresh the page, where you just like pick and choose what content needs to go into this context for the LLM to take the next step? Like if the next step for the single agent is to schedule, you don't really need information about what is the bank account of the customer, for example. Or if the next step is to like, send an invoice, you don't need to know how many sessions they are like they had on the whole, or maybe you need to know higher level information, and then you can compute the cost and give it to the send it to the client. So there are like multiple ways, multiple techniques that you can use to filter out the context that you need to give to the single agent. But the idea is that spending time on context engineering for a single agent is way more valuable than trying to make your multi-agent system work in a lot of the use cases. Now, does this mean multi-agent systems can't do context engineering? Not really. Like in multi-agent systems, you can still do context engineering for each individual agent, but the fact remains that you are still dealing with coordination challenges. In the case that like you might solve context engineering for like a billing agent and a scheduling agent, but you are essentially having two different methods to do that. And then you still need to solve the triggers problem, whether updating an agent should trigger the other agent. And the examples that I gave are like limited or like foreseeable, but you can end up with all sorts of corner cases when you're building an enterprise system with multiple agents. So the idea again is to iterate with a single agent, focus on like solving context related agents, and then only go to new agents or like add more agents to your multi-agent system when you see a clear gap or a justification that you can only achieve it with that. And then you can think about the delegation part. Now, does this mean like I should never build multi-agent systems? Not really. Like there are well-known or well-documented multi-agent systems in the industry, but you also kind of need to be more intentional about whether I do really need to go this way or not. So a quick rule of thumb is go for multi-agent systems where the tasks are parallelizable. LLMs are extremely chatty. Like if you don't set the context in the right way, you might have seen this when you're talking to even say like ChatGPT. If you don't give it the context, it goes with a bunch of assumptions and it will not exactly give the answer you need. And now imagine like putting a bunch of these systems together where each of them is not talking to them in a detailed way as required. It can just like keep going into loops and then like not do the right thing. So it's nice to build multi-agent systems to actually focus on problems where things are like parallelizable. Like, for example, research tasks, deep research systems are a very good example of how you can parallelize things and then make sure you're saving the time, but also spending more tokens. It's okay to spend more tokens, but you want the right information, but at a quick latency. So in those kind of cases, you can have like the supervisor kind of model where there is like one agent controlling everything, and then you spin up like sub-agents as possible. We'll go into an example cleanly on how that is built. But again, here, multi-agent systems are useful, and I'm still recommending it not to go with like the swarm pattern where every agent is talking to every other agent. Have some sort of control on the coordination still, so that you can identify what kind of behaviors that you can delegate to each agent, and then go from there to like more complexity and more agency for the entire system. So as an example, we will talk about like Claude Code and the Claude Research sub-agents. So Claude has this terminology called sub-agents where each agent or like the main agent can spin up lightweight helper agents, which can handle a specific task. So there is no context shared between them. So the main agent is the one that still sees the entire context, but sub-agents are something like your helper functions in code where you ask it to do explicitly one thing, but they are intelligent enough on their own. Like they have access to their own tools, they have access to their own context and the instructions that the main agent has given them. And you quickly, like each of the sub agent can basically run their own thing and then come back to the main agent. But hey, this is the thing that you need to know. So how is it useful in general? This kind of separation helps the main agent to avoid focusing on the minute details on how a sub-agent's work is done. The sub-agent's responsibility is to take the problem, do its thing, and then only present the final solution, not the thought process that it went through to the main agent, because it essentially is responsible for handling that sub-problem and providing the main agent the information. So this is useful for like, parallelizing tasks when you're like, say, like writing code, for example, which is very like parallelizable. Like you need to write two different classes which are completely unrelated, but then at the end of the day, you can figure out how they fit to each other. So something like that can be parallelizable with this. And coming back to our previous example of deep research, this is a blog that Anthropic has published on how they built their deep research system, which they call advanced research. And this is the high-level architecture. So on the right side, you can see, or maybe let's start with the left side. So this is the kind of queries that the deep research is expected to handle. For example, like what are all the companies in US working on AI agents in 2025? Make a list of at least 100. And then for each company, get me all of this information. So essentially, you are having this highly parallelizable task where you have to figure out what is the process that you need to do for each company. But once you've figured that out, you can easily spawn multiple sub-agents to take care of this particular task for like a subset of companies. So this is the system architecture on the right-hand side, where you have this lead agent, orchestrator agent, supervisor agent, bunch of names for that. But the lead agent has tools, like you can plug it in with like MCP tools, search tools. It also has the ability to start a sub-agent and then complete a task for the sub-agent. So the idea is that you take this query and then the lead agent kind of figures out, okay, the user needs to do this. So then it'll go and say like do a couple of web searches and identify what does it actually mean to identify like what is the companies that are working in in building AI agents. So it gets like a list of company names, for example. So that initial part is serial, it is like only a single thread kind of operation where it's doing tool calls to identify a list of company names, and it also comes up with a plan for each subagent to say, these are the list of companies that I'm going to give you, and this is the kind of process that you need to do. Like maybe look up the documentation page, look up the about us page in the company, and then also find any news articles that talk about this, like fundraising, for example, of these companies. And these are the directions that the lead agent can give, but it does not actually do the work. It just gives you instructions and then passes to sub-agent. Now imagine Claude, like say, splitting it up into 10 sub-agents, and then each company is handling with like 10 company names. Each sub-agent is handling 10 company names. Now all of these sub-agents go do their thing, follow the task, and an important part here in terms of coordination is to reduce the minimal work. So for example, in the hypothetical scenario where lead agent just gives you company names, but doesn't really tell you what to do, now each sub-agent can basically do their own thing, like come up with their own hypothesis. And when they return the results back to the lead agent can easily get confused because I expected results in one format, but now I'm getting things in 10 different formats. So that's exactly where multi-agent systems can become complex, because you would really need to be extremely specific in terms of what you expect from these sub-agents and what is the result format that you need to take care of. And then Anthropic in this blog, it's a nice read. You can basically look at it for some of the techniques that they've used in making the system work well. One of the technique was something like lead agent context window can easily overflow. So they have this memory on the side where it can like keep writing important parts. For example, you are dealing not just with this lead agent and sub-agent kind of system, but any of the systems can go down at any time. So you need to make sure that you're remembering all the state. For example, if say like lead agent created the plan and then went down, you really don't want to like repeat the same process. So you can just like look up your memory if there was an existing plan that was devised for this query and come back to this and then hand it off to the sub-agents. So this is an example system. And then the pros of the system we have been discussing passively over the last 5 minutes is parallel execution, for example. You can pursue basically any number of sub-agents based on how your context or like cost appetite is, and then quickly answer a query. And ability to scale past single agent limits is extremely important in these kind of queries. Like imagine a single agent doing all this work. It would just go in like a step by step, and it will take quite some time. Whereas here you can just like scale and then also get multiple or like varied information. So in Anthropic's evaluation, they found that multi-agent systems perform like 90% better than single agent systems in terms of research scenarios. Also, as I said, like, ability to reduce end-to-end latency because you're essentially parallelizing. Also, you can specify token budgets for each of the sub-agents so that you're not spending too much time on like researching first 10 companies and not researching like the last 10 companies, for example. So kind of making sure there's equality of time invested in like all of the different sub-problems of the research that you're trying to solve. Now, yeah, some of the cons of this system is you should be willing to consume or like absorb high computation cost. Like you're essentially spinning out sub agents, but as I said, each of the agent does really need some extra additional LLM calls to set the context and do the right thing. So in terms of Anthropic's blog, they found that multi-agent systems can use approximately like 15 times more tokens in increased operational cost, because essentially they're like chatting multiple times to make sure everybody understands the context. Also, with supervisor kind of systems, there is coordination challenges, but you can imagine them being off the charts if you're actually building it in a swarm kind of state. And then this is the part that we've been talking about, that this kind of system, this kind of lead agent and search sub-agents being spun up is suitable for parallelizable tasks. But if you do sequential tasks, then it's not super suitable. For example, if your research on the first 10 companies impacts your research on the next 10 companies, then you can't really parallelize this, right? You have to let the single agent do its research, complete it, gain any observations, and then like change the game plan for the next 10 companies, for example. If you want to build a system that way, it's multi-agent systems like what we discussed is not a good way to build that. And then again, like there is a lot of engineering overhead that comes in when you want to build. It's a classic single node system versus distributed node systems that you build in computer science, where handling more things at once increases the complexity and gives you more power, but gives you more responsibility as well on how do you handle that. Now, this is a very important slide that we want to always like mention in terms of how do you actually build these systems and evaluate them in enterprise setting. Downloading a library and quickly creating like, you see like this travel example that is floating around everywhere, where there is a booking agent, there is a planning agent, and there is a billing agent, and everybody just talks. And then there's like a simple example, like you can try out a quick demo and then everything works. But then when you go and actually deploy it in your enterprise setting for your use case, you see all sorts of problems coming. The reason we want to emphasize this again and again is that evaluation of a single agent system itself is pretty complex. And I'm talking about the type 2 agents that we discussed, where agent has the planning autonomy and the tool calling autonomy as well. You're not building a workflow agent. Where in the workflow agent, it's easy to like distinguish what are the exact responsibilities of each step. So you have like very constrained set of evaluations. But in the type 2 agent, let's consider just like a single agent system. There are a bunch of things you need to evaluate for them, right? Firstly, you should understand whether the system is like achieving your end-to-end goals. Like, for example, if I want, take the system of like Aishwarya's COO agent, is it doing the right thing in multiple cases? Like, say, the client responded with like session details, but is not paying. Do I need to get notified of that? Or like the client is not responding to the initial email, do I really, how do I make sure that the client, but my agent is not sending a billing invoice for them without even responding to the contract, for example. So these are things like end-to-end goals, is the answer accurate, hallucination, and all of these workflow checks can be done. And then there's also planning accuracy. So the agent system prompt that you give is highly valuable in understanding what it needs to do. And then there is also all additions of like tool descriptions and MCP server tools descriptions that go into it. So you have to make sure that agent is doing the right thing. What I mean by this is like come up with some, say like 10 to 20 examples, even at a basic level, and then make sure that the agent is taking the right step of planning and it has the right context or the tools that it needs to use, and then it's doing the right thing. So this is one other set of evaluations. Another set of evaluations is about tool calling. So you need to iterate multiple times on your tool descriptions. Just because you put a tool that book a flight doesn't really mean the agent will call it in the right time in all the cases. The tool description needs to be very explicit about what it's supposed to do, what it can do, and what it cannot do. And then you also need to have the issue of agent calling the tool, but with incorrect arguments sometimes. So this is another spectrum of things that you need to care about. And then, as we said, memory access. The reason we also we also have emphasized over single agent systems is because memory access is a complex thing, and you also need to identify whether the agent is doing the right thing at that time. So whether it's retrieving the right context, whether it's looking at the memory at the right time or not, and then whether it's remembering something where it's supposed to remember that. All of these can also go into like an evaluation criteria for single agent systems. And then efficiency as well. Like, as I said, LLMs can be chatty, so they can just take like 20 loops to do something if you don't write your system prompt well. But if you write your system prompt well, and it can actually do it in like 3 steps, which is the most ideal way. And then now a new case comes in, and then it again taking 20 steps. So you need to make sure that LLM is not becoming expensive when you're wanting to achieve a outcome. So that is another direction where you need to evaluate your system on. So as you can see, there are like a bunch of cases that need to be evaluated for single system. And now if you go for a multi-agent system, you're complex, you're making this even more complex, right? Like each individual agent needs to be evaluated using all these goals. And then you also need to make sure that the communication overhead is manageable. Like you're not setting the context again and again and again. And like sub-agent systems, for example, are not repeating the work. That's the redundancy part here. Like you should make sure that you did this is like a regular human interaction in the team, I guess. You should make sure that the work you've done is documented in a way so that others can reference it and also not repeat the same work that you're doing. So these kind of patterns are very important when you're building out these systems. So to summarize what we've discussed about single and multi-agent systems, a lot of enterprise tasks typically are complex, but also need a lot of back and forth. And there are like interdependencies. And not many, you can just imagine different cases in your own company, right? Like not many use cases can be just parallelizable that you can start doing 10 things at once and then somehow like digest the information of the 10 things. So that's exactly why we recommend like, going with single agent system first, solve the use case. And if you feel like you're not hitting the sweet spot with latency and the task complexity, that's when go to multi-agent systems. And also then go to a supervisor or an orchestrator framework, and then move to this swarm kind of framework where every agent is talking to every other agent. And use them with care. Multi-agent systems do not just like, git commit push and then like deploy to your production systems. Have extreme care in terms of evaluating using all of these criteria and only then deploy. And then also understand that context engineering is important for like even a single agent system. So nail that problem first and then kind of spawn it off to different agents as well. And this is a kind of undervalued but like extremely important thing that is happening in the industry. Is many people have opinions without actually having building products, and it's easy to get lost in like an ocean of opinions over there. So the most valuable advice we can give you is to get your hands dirty. You are the person who knows your enterprise problem. You're the person who knows the complex set of actions that need to be taken to solve that task. So essentially get your hands dirty, build your prototype, and then like, establish your opinions. Maybe for your case, multi-agent systems do make sense, but you'll only know that when you actually build it with a single agent system and then identify the drawbacks and then go for that. So again, like it's a bit of gray area, and then the human expertise comes in, especially when you take these gray areas and then formalize on what steps need to be taken to actually come out of this gray area. So getting your hands dirty is like the most important thing that you can do to solve these problems. With that, I think I'm also slightly over time, but I hand it over back to Aishwarya.
Thank you. Thank you so much, Kiriti. This was a lot of good information. Let me go back.
Do you want to share your screen or should I?
I can share my screen.
Awesome.
Okay, this is the part where we do the paid ad, folks. Thank you for attending. We also do a 6-week course. And remember that when we talk about agents and all of this, we assume that you come with a background of, good amount of prompt engineering and all of these things. And these 4 sessions were also part of our 10-day Agentic AI course. But each of these concepts require much more deeper understanding if you're building for the enterprise and if you're looking to
I should have quick, sharing your screen.
Oh, okay. That is very weird. I thought I was sharing.
We could see it.
Oh, okay. Then maybe.
I see. Then
Okay,
I'll just roll with it. So this is the 6-week course. We are almost 90% full at this point. So we'll be taking enrollments maybe for the next 2-3 days. And there are a bunch of capstone projects. I think these came with your emails as well. You can see what our students have been up to. A lot of the work we do is around intentionally building enterprise systems. And there have been questions around what background I need and all of that. The only background we ask for is some coding in your maybe 10 years ago, 15 years ago, but we definitely will push you to be more hands-on. We'll give you 2 tracks. You can either do low code or with code. For low code, we use Langflow, and for code, we use LangGraph. And a lot of the course will be not just teaching a checklist of concepts to you, like this is RAG, these are agents. It will be more about thinking behind the thinking, like understanding how you should be intentionally building these systems so that you can scale them. AI is a very quickly moving space, so you need to move with some foundations that will not change in the next 2 months or next 3 months, and that is what this course is going to be. So if you like our teaching style, you want to continue, this is a code you can use. The code final10, and this is the link to the course. And just a heads up that we are 90% full, and we close registrations in the next maybe 2 or 3 days as soon as we're full. So make sure that you claim your spot if you're interested. We also have an October cohort. If so the next cohort starts next Saturday. If you don't have the time, you can join the October cohort as well. That
I also quickly want to double click what Aishwarya was saying about AI is evolving. There's like a good and bad parts of it. Like there is so much research happening, and there's so much like complex systems that are being built. But also there are like new terms that keep coming up every time, and we really emphasize on like building the foundations correctly, so that if something happens after, like a new thing happens after the 6 week, you really should be able to be in a position where you take that new term and map it onto whatever you have learned. So that's like what we really focus on, and it's essentially like what comes across in our like sessions like this as well, and even in the course. So that's key learning that I have had to internalize when I've been like learning the systems like from the start.
Awesome. On the recordings, you will get them, like we mentioned. There's also another session tomorrow morning, which will kind of end all these sessions. If there are any questions regarding our course, please write to us at problemfirst.ai@gmail.com. Right? It's super hard to answer all questions. This email is also there on our course page, right? If you have any questions around what's being used, is this suitable for me and stuff like that, and our course team can help reply those. All right. Thank you so much. No machine learning or deep learning background is required for the course. For the 10-day course, Mahtab, I thought most folks came from there, but let me just give you a link of how to get there.
While Aishwarya is doing that, I want to answer the question that Akshay asked at the start of the session about MCP and A2A. Like the question was, if MCP server itself can call an agent, does that count as an A2A interaction? It does count as an agent-to-agent interaction, but the A2A framework, if you look at it closely, there's also a way of like suspending execution of an agent and coming back to a different agent. That kind of feature gap was what we talked about yesterday in the protocols. So it does count as that, but then it needs more sophisticated handling.
Awesome. Divya, great question on centralized place to get access to all of these sessions. That would be the QR code on the left, the other free upcoming and past sessions. We have been doing sessions since the start of this year. Most of them should be available there, either a recording or a sign-up link to the future thing. Mayank is impressed with our 10-day course. Thank you so much. I will
put
the link again. Put a lot of effort into making it accessible for everyone. So do sign up for it. Like these 4 sessions were part of the 10-day course. The 10-day course included a bunch of emails as well as these sessions. So you could probably do that 10-day course even after you watch these sessions to make your foundations a bit more stronger. So Megan, thank you so much. All right. See you everyone tomorrow. Thanks for attending and have a nice weekend. Bye-bye.
Awesome. Thank you, everyone. Bye.